Macy the Science Gal.
Macy the Science Gal.
Macy, 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 Macy.
Ecology is the study of ecosystems. Science rules. T-minus 5 seconds.
Macy the Science Gal.
Wow, it sure is hot out here, but I'm glad I brought my popsicles. I think I'll just set them down here quick and go grab some sunscreen.
Soon, Macy the Science Gal's popsicles disappeared, and she needed evidence to prove who could have done such a thing. So naturally, she used chromatography.
We're going to be using paper chromatography to see who the popsicle thief is. I've melted a cherry and a grape popsicle, the popsicles in which I brought to the backyard, to see what their chromatography is, using paper and isopropyl alcohol. First, you're going to fill a beaker with 60 milliliters of isopropyl alcohol. Next, you're going to take your chromatography paper and make a mark so it's somewhat off of the paper, but not too far. In this case, we're going to be marking it at 15 millimeters. Like so. Next, you're going to get your two solutions. We have our grape and our cherry popsicle. You're going to put a dot of dye, or a couple dots of dye, on the line of each solution. Now that we have our dots on our paper, we're going to stick them in our solution, our isopropyl alcohol. We're going to stick our chromatography paper in dot down, being sure not to get any of the isopropyl alcohol directly on the dots, because if we get them on the dots, the colors will separate on the dots themselves, and they won't separate upward. A retention factor is a ratio of how far a color traveled. We're going to use this equation to find the distance of red and blue. Using a ruler, we're going to be marking when each color ends. Red ends here. And blue ends here. Our whole distance is our mobile phase, from this line to this line. And from this line to this line is our distance in which our component traveled. Blue traveled 8 millimeters. The whole mobile phase traveled 18 millimeters. Now let's go do the math. If our RF value will now equal 8 millimeters over 18 millimeters. This is equal to 0.44, which defines our blue/grape chromatography. Now that we know the RF value of our grape substance, let's go gather some evidence.
Hey, what's up? What's going
nothing
on?
much. I'm just trying to figure out who ate my popsicle.
Oh, wasn't me. I didn't have no popsicle.
What's that on your face?
Nothing.
Nothing, he says. Now, if you two are playing together, what does that mean for you? Don't look like you're innocent. Let me look. What is that on your collar? Nothing, they say. Now that we've gathered some evidence, let's see if the RF values match. Even though this one looks purple and this one looks red, they might have a different RF value, meaning that Bella and my dad didn't eat my popsicles. Let's go. Let's repeat the same process. The distance to the blue is about 7 millimeters. And the whole mobile phase is 16 millimeters. Our RF value equals our component over our mobile phase, giving us a total of 0.44. Wait a minute. It's also 0.44. That means I know who our culprit is. Now let's measure the red just to be sure. This one says about 10 millimeters. And this one also says 10 millimeters. Finally, I know who ate my popsicles. I used chromatography and I found that you ate my popsicles.
What popsicles?
The grape and cherry popsicle.
I didn't eat a grape and cherry popsicle. I would remember that.
You ate a grape popsicle. Science says so.
All right, you got me. Bella ate it. Bella ate it. Bella ate it. Whoa! Someone left the popsicle. How about her eat it? Grapey. Don't tell anyone our secret.